Okay, you guys, easy lesson. Well, pretty simple lesson for today. You're definitely going to want your calculators or whatever you guys are using. I would probably recommend your calculators. So we're still in 11.1. What we're going to learn today is something called standard deviation. And it's a formula, but obviously all you need is really your calculator and just have to set it up. And then everything else should be pretty simple for there. So, oh crap. So what is standard deviation? Well, what we're learning today, yesterday you guys learned measures of central tendency. Measures of central tendency, we had mean, median, mode. Today, like I said, what we call this is measures of dispersion. And here's what measures of dispersion are. They are statistics that tell, it's going to be terrible wording, but hold on. It's not going to be the best, you, how dispersed. I know it's not good to use part of the word in here. But what we could say for dispersed means how spread out. The data values are. And with that, you guys have two different ones. You have something called standard deviation, and you have the range that tells you how spread out there. But yesterday I spoke about range, so we're just going to learn standard deviation today. And again, it's just the formula. And then I'll show you guys an example. So you do need to understand what it means to be, or what the definition of standard deviation. So what it is it describes the typical deviation or difference between a value and, here's the key word, the mean. So you're kind of seeing how far away a value is from the mean. So with that in mind, obviously you guys should realize you have to calculate mean. It's really important, obviously, to have the mean. So the mean is your average of your data values and so forth. So you can have how do you have a low? I'm going to put SD for standard deviation. A low standard deviation would be data values close together. And obviously, I'll give you guys an example to make sure you guys know. If the values are close together, what that means is that all the values are close to the mean. And again, mean is your average. So for example, if you could say 90, 89, 85, 93, something like 87. All of those values are pretty close to what the average would be. You have basically your highest value is 93 and your lowest 85. So let's say the average, could be like an 89. They're all pretty close to 89. So that's a low standard deviation. Okay, you would probably prefer a low standard deviation when I'm testing you. A high standard deviation, obviously, are data values spread out. So obviously what that means is they are further or farther from your mean. So for example there, I had a 50, a 61, 72, a 90, a 99, something like that. Obviously, they're further spread out. That's not going to be a super high standard deviation, and we're going to be able to figure out the standard deviation. But something like this would be low, and something like this would be higher because the numbers are further spread apart. Okay, so how do we calculate the standard deviation? Well, we have to use a formula. And like I said, thank God you guys aren't being tested on this for right now, but you have to know how to use the formula and know what each value means. Okay, so here's how we calculate our standard deviation. I'm going to write the formula, and then I'm going to explain it with columns because I know it's going to look weird. Well, first I should say this sigma, that's what it looks like to be standard deviation if you have calculators or whatnot. So if you see that, that means, again, this is called sigma as well. It means we're calculating standard deviation. So, there we go. So, there we go. Here's what it is. It's the square root of, you're taking the first value minus your mean squared, plus you take the second data value minus, your mean squared, plus you do all of that to all of the data values. So we'll say data value, we don't know, however many you have, minus my average squared, and then you're going to divide that by, again, the number of values, and then you're square rooting that whole answer. And again, n is the number of values, n number of terms. I know it looks a lot more complicated than it is. I'm going to show you to you in the column with all the numbers, so to make your life a little bit easier. All right, so let's take a look at an example. It's going to be a little longer only because it's what I was going to do in class, and I don't want to shorten it because I don't want to have to figure out the answer right now. So bear with me. Okay, so first question, pretty much only just going to do one question, you guys. So make sure you're okay with it because I'm going to ask you a question off of that. It doesn't pay for me to do so many of them because they're repetitive. But I need you guys to make sure you know how to do this. So here's my data values. I know they're long, just bear with it. I'm only doing one example of standard deviation. So there's your values, and I want you to find the standard deviation. Well, first of all, think about this. You're going from 14 to 32. I would say it's going to be not a small standard deviation. So here's how you do the chart. Xn, you're going to write our values. Then, actually, I'll do one thing at a time. So we have 14, 17, 18, 19, 20, 22, 24, 30, and 32. Okay. Now, the next column, you're going to do X with the bar over it because it should make sense from the formula. One of the main things we need is our average. So this is the average of all the numbers. So you want to add all of these numbers up and divide. So the average of these numbers, let's say to the nearest, oh yeah, I can't see that, to the nearest 10th is 21.8. So 21.8 is in this whole column. Oh, actually, you can round that number because I rounded the number. So I'm going to use 22. It's okay. You guys can use 22 to make your life easier. It's approximately. So if you're off by a few decimals, it's totally fine. So we're going to use 22 for the average. Now here's the next column. If you were to look at that formula I gave you, we want to figure out what each data value minus the average is squared. So I would do 14 minus 22, and I would square it. 17 minus 22, and then I would square it. 18 minus 22, square it. 19 minus 22 squared, and here are their numbers continuing. Oops. So that's that column. And then, if you look at the formula, so what we did here was we calculated the average. Okay, now we calculated what was in the parentheses, squared, yes. Now, if you think about this whole formula here, this is me adding everything up and dividing by the number of values. So that is the average. So our next column, you are going to basically find me the average or the mean of the column prior or the column before. Okay, so we're going to add all of these values up. We're going to divide by the number in them. And here you're going to get your X average, or your average to be 31.1. 0.7, let's round it, and let's use 32. And then your very last column is, you guys are square rooting, we'll say the answer before. So in this column, I'm now going to take the square root of 32, and I'm going to round to the nearest tenth, and you get 5.7. So 5.7 is our standard deviation. So just take a look at that. I know it looks complicated, but it's really not. You list all your values, find me the average of them. Then you take, which is why I set it up like this, the data value minus my average squared. And then you want to average that. So you have data values, average. You know, do these two, subtract them and square them, average, and then you square root your final answer. So just make sure you guys have that heading on your paper. And so you guys know what to do. It's also in your textbook. Now, here's the question I can ask you based on this. I can say, how many standard deviations away from the mean is 30. So again, this right here is one standard deviation. So one standard deviation is 5.7, really important. Okay, so I want to know how many standard deviations away from the mean is 30. Well, think about that. What is the mean? The average was 22. Okay, so I can do 22 from 30. And again, standard deviation is going to be positive. So here's what you guys are going to do. The absolute value of your mean minus what I want, which gives you 8. And then, obviously this makes sense, your standard deviation, one standard deviation is 5.7, so take it and divide by 5.7. There you go. And you get 1.4. So watch, how about if I asked you this? How many standard deviations away from the mean is 10? Okay, so here you guys go. Same kind of thing that you just did. I'm going to take 10. I'm going to take, doesn't really matter, 22. I'm going to take the mean, which is 22, and I'm going to subtract the number that they asked. And you guys are going to get 12. And you're going to take that and divide by 5.7 because that's one standard deviation. And you should get about 2.1. Those are the only really questions I care for of that. One other thing maybe I would like you guys to jot down, because I had another example, but it's repetitive. Maybe you guys can just jot this down, what an outlier is, because that's important in statistics. An outlier, first of all, it affects the measure. And it should make sense of central tendency, put CT for central tendency, and dispersion. So what we learned today. So an outlier can give misleading information or impression of the data values. Because obviously if you have, it should make sense. If you have a very low value, and I wanted to find your average, like of a class grade, let's say, obviously someone's low value is going to greatly affect the average, where let's say if the person was absent for over a week, that's not a good idea. So which outlier affects the most? And it would be a mean, right? The lower it is, the worse the mean's going to be. It's not going to be a pretty good representation of what your average is. And the mode it affects the least, because I don't care. I'm looking for the one that occurs most often. Okay, so again, it's just the formula. Hopefully that was easy. Your homework is a worksheet. Your homework tonight has standard deviation and what you learned yesterday. So just make sure you guys are using your notes. Show me all the work, and you got this. Okay, bye.